Jupiter and Saturn get a lot of attention because they're so big. But Uranus, as it turned out, proved more fascinating than astronomers on Earth had ever dreamed.
The most obvious oddity is that the planet appears to be tilted on its side. This means the sun shines more directly above its polar regions than its equator, as you can see from the position of the delicate rings. No one knows for certain why Uranus is tilted over 90 degrees on its axis. Some astronomers speculate that a planet-sized body crashed into Uranus early in its history, knocked it on its side, and formed all the moons and rings now circling around the planet. Uranus is about 4 times the size of Earth. It also appears that the 7th planet from the Sun has a rocky core, about the size of Earth, and is surrounded by a sea of liquid water. This sea is totally unlike any earthly ocean. Its featureless surface covers more than 2.5 times the area of the entire Earth. The immense methane atmosphere and the intense gravity of the planet compress the water so much that it generates its own electrical fields. As a result, the water becomes superheated. Only the heavy atmosphere bearing down on this strange sea prevents it from boiling. It's an unexpectedly hot world to find orbiting so far from the sun. This electrically charged ocean produces 2 interesting Uranian features. First is a strange magnetic field that rotates on a highly irregular orbit about the planet. The magnetic field, in turn, creates the second feature. It is something scientists call electroglow. Uranus, as it orbits in dark space, has an eerie nebulous glow of electrically charged particles surrounding the entire sphere. The 5 large moons of Uranus are all made up of water ice with perhaps hot rocky cores. They are named Ariel, Umbriel, Titania, Oberon, and last, but certainly not least, Miranda. Most of these moons show signs of recent geologic activity. Of the large moons, Miranda is by far the most remarkable. Its surface looks as if someone took a cosmic-sized broom and swept across its face.
Then there's Neptune. Orbiting 30 times farther from the Sun than the Earth, Neptune is most certainly a very cold place. And very little was known about the 8th planet until recently. With the Voyager's encounter, we've learned Neptune's atmosphere is surprisingly active.
This atmosphere, like Jupiter's, has a multitude of bright and dark bands. Bright white and dark black clouds take shape and then dissipate in the upper atmosphere, just as they do on Jupiter. And, once again like Jupiter, Neptune harbors a huge storm in the atmosphere. The scientists who found it appropriately dubbed it the Great Dark Spot. Above and below this storm, small white clouds dash around at over 1,000 miles an hour. Some of them go in the same direction as the dark spot, and others move the opposite way. Scientists call them scooters. Neptune is about the same size as Uranus, but it's not tipped on its side. Its orbital axis is a relatively average 28 degrees. The analysis of Neptune has shown that it's made up of a solid core of rock and water ice. But there appears to be evidence of methane ice as well, creating a chilly surface temperature of some 200 degrees below zero.
Nonetheless, the measured radiation from the planet is greater than that which can be accounted for by the meager amount of sunlight that strikes it. Like Jupiter and Saturn, Neptune is mysteriously giving off more heat than it's receiving from the Sun.
Neptune has 2 significant moons. Triton is about 2,000 miles in diameter and has a methane ice coating. Nereid is barely larger than an asteroid at 185 miles in diameter. Triton's orbit is completely opposite that of the rotation of Neptune, so it's unlikely that the two formed together out of the solar nebula. Scientists think Neptune captured this moon later. During part of its orbit, Triton passes very close to the planet's surface, and its gravity raises tremendous waves of liquid methane. These waves follow the moon and their gravity tugs at it. This slows the satellite, causing it to come ever closer to the surface. One day, Triton will pass too close. Neptune's gravity will tear the satellite apart and create a new ring system around the planet.
The outermost planet of the solar system is Pluto. Because of its small size, 1,400 miles, Pluto's status as a planet has been a subject of debate. It's only about half the size of our moon, and most of that is made up of methane ice with a little rock thrown in for good measure. Pluto does have a satellite, Charon, so it has managed to hold its rank as a planet so far.
The imaginary picture would probably be like a cratered surface on Pluto due to impacts, but white due to the frozen methane frost on the surface, making it rather highly reflective.
People on Earth will experience nearly 2.5 centuries during the time it takes Pluto to go around the Sun once. In other words, Pluto's year is about 250 times longer than a year on Earth. Pluto's average distance from the Sun is 3.7 billion miles, and that makes it the 9th planet. But its orbit is very lopsided. Today, it's only 2.8 billion miles from the Sun. For the next few years, it'll be closer to the Sun than Neptune is. Besides swinging way out and back in, Pluto's orbit tilts at an angle different from all the other planets. Its satellite, Charon, was unknown until 1978. It's about 475 miles in diameter and orbits Pluto once every 6.4 days. This matches exactly the rotation of its parent. To an observer on Pluto, the moon would always be in the same spot in the sky. The Sun, seen from the surface, would shine dimly like a distant star. Pluto is an appropriate name for the 9th planet. It's the domain of the god of the underworld, the god of an ice-cold hell. Pluto and Charon will never be high on our list of planets to explore. They're simply too far away and much too cold for us. So where do we go from here?
The planets in our solar system may be our closest neighbors, but they're still very far away. To give you an idea how far away some of them are, think about this. Light travels at 186,000 miles per second. The radio signals sent by the Voyager spacecraft travel at the speed of light. So even traveling at the speed of light, it took Voyager's signal 4 hours to reach the Earth from Neptune. To look at it another way, were you able to drive your car at 100 miles an hour for 24 hours a day, 365 days a year on a highway that led to Pluto, if there was one, it would take 4,189 years to get there. The distances between us and our planetary cousins are truly astounding. But thanks to our technology, they are definitely within our reach. We will have to begin our journeys to the stars by first exploring and then learning to live on the worlds of fire and ice.